Okay, so in this example, we are going to determine whether the series sum n equals 1 to infinity of n factorial over e to the n squared converges or diverges. Okay, so again, this is not a geometric series, not a p-series, and seeing the factorial and the exponential is a really good hint that we want to use the ratio test. Okay, so when we use the ratio test, we're going to take the limit as n goes to infinity of the absolute value of the n plus first term divided by the nth term. Okay, so probably a common mistake I would see on something like this would be replacing the n squared here with an n squared plus 1, but remember you are replacing n with n plus 1, so it's really n plus 1 squared. Okay, so everything's positive, so we can drop the absolute value bars. We can simplify this as n plus 1 factorial over, I'm going to simplify this. This is e to the n squared plus 2n plus 1. You FOIL out the n plus 1 squared. You get that multiplied by e to the n squared over n factorial. Okay, we can cancel some things out. We can cancel out n factorial, cancels with n factorial here. And we can cancel out an e to the n squared with an e to the n squared. Okay, so when we take this limit now, we're taking the limit as n goes to infinity of n plus 1 divided by e to the 2n plus 1. Okay, so if we end up with this, we can use L'Hopital's rule. Okay, so you get infinity over infinity. So you take, this is the same as the limit as n goes to infinity of 1 over 2e to the 2n plus 1. That's the derivative of this. And then as n gets really, really big, we get 1 over a really, really, really big number. So that should be 0. And 0 we can agree on is less than 1. And what this tells us then is, so the series converges by ratio test. Thank you.